Okay, we did come across lots of examples where we had indeterminate quantities and how we could simplify it. Now, this particular section will be taking up only those examples where we can avoid expressions which are we cannot avoid. We have to convert an indeterminate expression to a determinate expression. This is generally done sometimes by factorization, sometimes by multiplying the numerator and denominator by the same factor to remove the indeterminate factor. Now let us see what examples we have in store. So we have this particular function here, f of x is 8x cubed minus 1 divided by 6x squared minus 5x plus 1. And you need to find the limit of this function as x is equal to half. If we substitute x as half over here, you end up getting 6 by 4 minus 5 by 2 plus 1, and you end up getting 6 minus 10 plus 4 by 4, which will turn out to be 0. So the denominator turns out to be 0, which is hence the expression could become indeterminate when x is half. So what do we do in such cases? We have to first check whether we can simplify this. So of course we can simplify this. We can write it as 2x the whole cube minus 1 cube, and the denominator can be written as 6 into 1 6. So we factorize, so 6x squared minus 3x minus 2x plus 1, which will turn out to be, using a cube minus b cube formula, it is a minus b 2x minus 1 into a squared, that is 4x squared, plus ab, that is 2x, plus 1 squared, that is b squared 1. And here if you simplify it, you end up getting 3x into 2x minus 1 into 2x minus 1. So that will give you 2x minus 1 into 4x squared plus 2x plus 1 upon 2x minus 1 into 3x minus 1. So this gets cancelled and you get this. You get a determinate quantity. Now here if we substitute x as half, the denominator is not 0. So now we find out f of half in such cases. So it will become 4 into half square 1 by 4 plus 2 into half, that is 2 into half, plus 1 upon 3 into 1 by 2, 3 by 2 minus 1. This will turn out to be 1 plus 1 plus 1 upon 3 by 2 minus 1 is half, which will turn out to be 3 into 2, which is 6. So the value of this function for f of half is 6, and since the function has become determinate now, limit of this function as x approaches half is f of half itself, that is 6, which is 6 itself. So among these, so this is a case wherein the expression is indeterminate, not for all values of x. For x is equal to half, the expression becomes meaningless. Now, as an offshoot of this, suppose we are not able to factorize this particular situation and you have this denominator as it. In such cases, what you do? Suppose the expression was, instead of this, suppose the expression was 4x plus 1 upon 6x squared minus 5x plus 1, and you have to find the limit of this when x approaches half. Now, in this case, it is not possible to factorize, so there is no common factor. In such cases, they say limit, this particular limit does not exist, because you can neither factorize and nor can you substitute the value of x as half, because that will give you an indeterminate value. In such cases, we say the limit does not exist in such cases. Okay, so the indeterminate cases, we make them determinate by factorizing the expression. So our answer is 6, our option is 6. Let's check. Yes, we do get it as 6. Okay, further now, here we have a situation. We have an interesting situation here. We have f of x, which is root 1 plus 2x squared minus root 1 minus 2x squared, the whole divided by x squared. Now you have been asked to find as x approaches 0. Now here again, if you put limit of this as x approaches 0, then the denominator will become 0 and the expression is meaningless. In such cases, what do? Whenever the numerator and denominator are in the form in the form root a minus b or root a plus root b, whenever the denominator or numerator is in this form, we say they are conjugate binomials. In such cases, we multiply by the conjugate. Now, in this case, the conjugate is minus. So, you multiply by root 1 plus 2x square plus root 1 plus 2x square. Right. But since you multiplied the numerator, to nullify the effect, you need to multiply, this should be 1 minus. The denominator has to be multiplied by the same. Remember, we have changed this sign, not the sign inside. Plus root 1 minus 2x square is what we get. So this is now in this format. So this is of the form a minus b into a plus b. So they'll give you root of 1 plus 2x square, the whole square, minus root 1 minus 2x square, the whole square, divided by x square into root 1 plus 2x square plus 1 minus 2x square. This on simplification will give you 1 plus 2x square minus 1 plus 2x square. These two get cancelled upon whatever it is, the same denominator. This will eventually become 4x square upon x square into root 1 plus 2x square plus root 1 minus 2x square. Now what is happening? The term which was causing us problem and making it indeterminate for x is equal to 0 gets cancelled, and ultimately you get 4. 4 upon root 1 plus 2x square plus root 1 minus 2x square. Now it becomes simple. It becomes a determinate function for x is equal to 0. Now we just need to find out f of 0. F of 0 itself is limit of this function now as x approaches 0. So it will become, now you just need to substitute the value 4 upon 1 plus 2 into 0 square plus root 1 minus 2 into 0 square, which will be ultimately 4 upon 1 plus 2 into 0 square is root 1 plus another root 1, that is 4 by 2, and it is 2. So the value of this function, limit of this function as x approaches 0 is 2. This is our right answer, and yes, we do have it that way. Okay. Now, here again we have a similar kind of a situation. You have root of x minus q minus root p minus q upon x square minus p square. We need to find the limit of this function as x approaches p. Again, here if we substitute x as p, the denominator becomes 0 and the expression becomes indeterminate for this value. So what do? We multiply by the conjugate, which is nothing but the same two things, x minus q, p minus q, and it will be plus in between. Plus root p minus q. Now this will now become root x minus q the whole square minus root x square minus p square into, this part is still left, that is root x minus q into root p minus q. This will now become root x minus q the whole square is nothing but x minus q minus p, minus of p minus q, which is minus p plus q, and this gets cancelled. X square minus p square can be written as x minus p into x plus p into 1 upon all these values. Now this will now become x minus p, which is nothing but this term and this get cancelled, hence you end up getting 1 upon x plus p into 1 upon x root x minus q, sorry, this is plus root p minus q. So now we need to find the limit. So in this cases, it's going to be nothing but f of p itself. Limit of this function now as x approaches p is f of p, which is going to be 1 upon p plus p into 1 upon, instead of x you put p minus q. This will remain as it is, plus p minus q. So this will now become 1 upon 2p into 1 upon 2 times root p minus q. So ultimately it is 1 upon 4 times p into root p minus q. So it's become 1 upon 4p root p minus q, and which is this particular value. So what we have done in this example, again we have multiplied the numerator and denominator by the conjugate of the irrational part of the expression, and hence we have that. All right, fine, we have it right. Furthermore, we have 2x squared minus 7x plus 6 limit as of this expression upon 5x squared minus 11x plus 2 as x approaches 2 is equal to so and so. So we need to find the limit. What do we do in such cases? We need to factorize this. So we have 2x squared minus 7x plus 6, and hence we write it as 2x squared minus 7x 12. So it will become minus 4x minus 3x plus 6 upon 5x squared minus 10x minus x plus 2. So this will be f of x. This on simplification gives you 2x into x minus 2 minus 3 into x minus 2, 5x into x minus 2 minus 1 into x minus 2. This will give you x minus 2 into 2x minus 3 upon 5x minus 1. So the expression, the function becomes this. So now we need to find the limit of the function as x approaches 2, which will be the same as f of 2 because the expression has now become determinate. It's going to be 2 into 2 minus 3 upon 5 into 2 minus 1, which is 4 minus 3, 1 upon 10 minus 1, 9. So it's going to be 1 upon 9. So here again we have done the exercise of factorizing the terms, and hence we get it. Yes, we do have it as 1 by 9. Further ahead we have this x cubed minus 5x squared plus 2x plus 2, x cubed plus tx squared minus 6x plus 3. Limit of this function as x approaches 1 is equal to what? Now even here we need to factorize. If you see, sum of all the coefficients is 0. 1 minus 5 plus 2 is 0. That means for the first expression, for x cubed minus 5x squared, if sum of coefficients for the numerator is nothing but 1 minus 5 plus 2 plus 2, 0. Therefore, x minus 1 is a factor. And here also it is the same. 1 plus 2 minus 6 plus 3, which is also 0. So for the denominator also it is the same. So we need to perform synthetic division. So for the numerator, if you perform synthetic division, you get 1 minus 5, 2 and 2. And you have x approaches. So x minus 1 is a factor. So you put 1 here, 1. 1 into 1, 1 minus 5 plus 1 minus 4, 1 into minus 4, 0. So that means the numerator is actually x minus 1 into x square minus 4x minus 2. Same way the denominator, if you take it into account, you get 1, 2, minus 6 and 3. And here you put 1, you get 1, 1 into 1, 1, 2 plus 1, 3, 3 1 is 3, minus 6 plus 3, minus 3, minus 3. So the denominator is x minus 1 into x square plus 3x minus 3. So this gets eliminated. So this is what the function turns out to be. So now limit as x tends to 1 is nothing but f of 1 itself, which will be 1 square minus 4 into 1 minus 2 upon 1 square plus 3 into 1 minus 3, which will turn out to be 1 minus 6 minus 5 upon 1 square plus 3 minus 3, which is 1, which is minus 5. So among these you get it as minus 5. Let's check. Yes, we do get it as minus 5. Furthermore, okay, here we have a function x cube minus t cube upon x square minus t square. Let's take this down. Is evaluated to be what among these? So let us take the function. As usual, we need to factorize this. So you have x cube minus t cube upon x square minus t square. So this will turn out to be a cube minus b cube, that is x minus t, into x square plus xt plus t square upon x minus t, and hence you get this. Okay, now limit of f of x as x approaches t will be the same as f of t now, which will turn out to be, instead of x you substitute the value of t, so you get t square plus t into t square plus 1 more t square upon t plus t, which will turn out to be 3t square upon 2t, which will turn out to be 3t upon 2. So among these you get 3 by 2t, that is 3t by 2 is the right answer among these. Okay, we do have it that way. Moving over to the next sum, we have a similar case of factorization. Now here you have 4x raised to 4 plus 5x cube plus 7x square plus 6x is equal to what? Now here the sum of the coefficients is not 0, but if you add 4 and 7 you get 11, and 5 plus 6, 4 plus 7 as well as 5 plus 6 both are equal to 11. That means x plus 1 is a factor. Whenever the sum of even coefficients is equal to the sum of the odd coefficients, that means x plus 1 is a factor. So we again perform synthetic division. So we have 4, 5, 7, 6, and there is one more term, that is a constant term which is missing, so we need to put a 0. And since x plus 1 is a factor, you put in minus 1 here, so you get 4, minus 1 into 4 minus 4, 5 minus 4 1, 1 into minus 1, 6, and minus 6, and you get 0. That means the other factor is going to be 4x cube plus x square, 4x cube plus x square plus 6x. Hence we get it that way, which can be further factorized, and you can take out x common. In the denominator you can take out x common. So ultimately the numerator becomes x plus 1 into 4x cube plus x square plus 6x, because even this term is 0. And the denominator you can write it as 5x raised to 4 plus 7x square plus x. So here you can take out x common and you get 5x raised to 4 plus 5x raised to 4 plus 7x plus 1. Now again in the numerator you can take out x common and you get x into x plus 1 into 4x square plus x plus 6 upon x into 5x raised to 4 plus 7x plus 1. So you'll find that this gets cancelled. So the expression becomes more determinate. And now this is nothing but f of 0. So it will give you 0 plus 1 into 4 into 0 square plus 0 plus 6 upon 5 into 0 raised to 4 plus 7 into 0 plus 1. Ultimately, this will become 1 into 6 in the numerator. The denominator is just 1 and you get it as 6. So, the value of this particular expression turns out to be 6, which is the same as limit of this function as x approaches 0 is the same as f of 0, which is turning out to be 6. So, among these, 6 is the correct option. Okay, we do get it as 6. Further ahead, we do a similar kind of sum. We have x squared minus 5x plus 6 into x squared minus 3x plus 2 upon x cubed minus 3x squared plus 4. So, numerator needs to be factorized, x squared minus 5x plus 6. So, if you take x squared minus 5x plus 6, you can write it as x squared minus 3x minus 2x plus 6 into this will become x squared minus 2x minus x plus 2. And the denominator we need to factorize. Now, how do we factorize in such cases? Sum of the coefficients 1 plus 4, 5 minus 3, 2. So, x minus 1 is not a factor. Sum of even coefficient is minus 3 plus 4, because even x raised to 0 is an even coefficient, is 1. 4 minus 3, 1. And here also you have 1. So, x plus 1 is a factor here. So, let's do x plus 1 as a factor. So, you put in minus 1 here. And the coefficients of this are 1, minus 3, 0 and 4. So, you get 1, minus 1, minus 3 minus 1 is minus 4. And you have 4, 0 plus 4, 4, minus 1 into 4, 4 minus 4. So, the other factor is going to be x square minus 4x plus 4. So, the denominator will turn out to be x plus 1 into x square minus 4x plus 4. And this will turn out to be, this one simplifying becomes x minus 3 into x minus 2. This will become x minus 2 into x minus 1. And this will become x plus 1 into x minus 2 the whole square. This one, this is nothing but x minus 2 the whole square. So, this term and this term get cancelled. And hence the limitation regarding the determinant, it being determinate or no, has been nullified, that is x minus 2. So, now limit of this function as x approaches 2 is nothing but f of 2 itself, which is going to be 2 minus 3 into 2 minus 1 upon 2 plus 1, which will turn out to be minus 1 into 1 by 3, that is minus 1 upon 3 is the limit of this particular function, which is also the value of the function when x is equal to 2. So, our correct option is minus 1 by 3. Okay. Alright, we do get it as minus 1 by 3. So, in all these examples, you observe a trend that we are going on factorizing. We may use synthetic division or just taking out common factor or splitting the middle term if it's a quadratic expression. But this is definitely required because these are all expressions which could become indeterminate for the given particular value of x.